Hello student, good morning. I am Dr.A.K.Sinha, Professor of Chemistry. Today I am going to start Electrochemistry, review of Electrochemistry. Already this chapter finished while discussing 12th. Now I am going to review entire chapter because many questions you have to solve when you will recall all the chapters important points, because many difficult type of question is asked in examination. Then for that you require complete knowledge of the chapter, particularly this chapter, to solve the questions based on electrochemistry. And now I am going to review the fundamentals of electrochemistry. What is electrochemistry? Electrochemistry is the branch of chemistry which deals with relationship between electrical energy and chemical energy produced in a redox reaction. That is, how chemical energy produced in a redox reaction. How chemical energy produced in a redox reaction can be converted into electrical energy, or how electrical energy can be used to bring about a redox reaction which is otherwise non-spontaneous. Again I am telling you, electrochemistry is the branch of chemistry which deals with relationship between electrical energy and chemical energy produced in a redox reaction. That is, how chemical energy produced in a redox reaction can be converted into electrical energy, or how electrical energy can be used to bring about a redox reaction which is otherwise non-spontaneous. What is electrolysis? Electrolysis is the process of decomposition of an electrolyte by passage of electricity through its aqueous solution or molten state, also called fused state. Electrolysis is the process of decomposition of an electrolyte by passage of electricity through its aqueous solution or molten state or fused state. Molten state is also called fused state. The apparatus used is called an electrolytic cell. Now, next point, the electrode which is connected to the positive pole of the battery is called anode. Here you should know very clear these things, concept you should know. Many students gets confused in anode and cathode. Now listen carefully. The electrode which is connected to a positive pole of the battery is called anode, and the negative ion which moves towards it are called anion. The electrode which is connected to a positive pole of the battery is called anode, and the negative ions move, and the negative ions which moves towards it are called anion. Means anion will go to anode. You remember. Anion will move towards anode. Correct? Anion is negatively charged. Here in electrolytic cell, anode is positive. Anode is positive in electrolytic cell. Okay, I will discuss galvanic cell. Their case will be different, just opposite in a galvanic cell, or also called voltaic cell. There are two types of cell. Galvanic cell is also called voltaic cell. This is the first type. And second type is electrolytic cell. Then now I am talking about in electrolytic cell, anode is positive charge. Correct? And an ion which is negatively charged will go to the positive charge, means anode in case of electrolytic cell. Correct? Now the electrode which is connected to the negative pole of the battery is called cathode, and the positive ions which moves towards it are called cation. Cation means positive charge. Then positive charge will go to the opposite, means negative cathode. Then the particles which is positively charged, that is called cation, and it will go to the cathode. Cathode is negatively charged in electrolytic cell, and anode is positively charged. And an ion which is negative, it will go to the positive, means anode. Correct? This you remember. And in a galvanic cell, case will be opposite. There anode will be negative and cathode will be positive. In galvanic cell, also called voltaic cell. Okay, reverse case. Any one you remember, other automatically you will understand. And you know that always ion will go to the opposite charge. Negative ion will go to the positive, positive will go to the negative. Correct? The negative ion is anion and positive is cation, you remember. Hence it will go in opposite direction. Now next I am going to discuss, that is Faraday's first law of electrolysis. Faraday's law I am going to discuss. Faraday's first law of electrolysis. Faraday's first law of electrolysis states that the weight of the ion deposited on an electrode is proportional to the quantity of electricity passed through it. You remember that in electrolytic cell, on cathode material will deposit. How much material will deposit? How much actually this thing cation that will convert to the metal. It will deposit on cathode. Then how much cathode, how much you can say metal will deposit on cathode, that I am going to tell. That is actually that you can tell only by use of Faraday's law. You can understand it by Faraday's law. First law I am telling you. Two laws are there. Then Faraday's first law of electrolysis states that the weight of the ion deposited on the electrode is directly proportional to the quantity of electricity passed. That is W, capital W is directly proportional to Q. You remember always on electrodes particles will be deposit, or you can tell ions will deposit. Then W is directly proportional to Q, capital Q. Or if this proportionality sign, if you will remove and equality you want to bring, then you have to multiply by some constant. Then W is directly proportional to Q. Now you can write W is directly proportional to ZQ, where Z is a constant. Then now W is equal to ZQ, and Q means C into T. C means current, T means time. C is current, T means time. Q means CT. Always remember, Q means amount of current. Quantity of electricity is represented by Q. Q is equal to quantity of electricity, and Q is equal to CT. C means current, T means time. how much current you have, how much current you have passed for how much time. Correct? That is a C into T. C means current, T means time. Then now W became W is equal to ZCT, where Q is the quantity of electricity in coulombs, C is current in ampere, T is the time in second for which current is passed. And what is the Z? Z is electrochemical equivalent. Actually, Z is a constant, but this is called electrochemical equivalent of the material deposited on the electrode. W is equal to ZCT, Z into C into T, very very important formula. While solving the numericals, you will require this formula. W is equal to Z into C into T, ZCT. Here Z is called electrochemical equivalent of the material deposited on the electrode. If Q is equal to 1 coulomb, if Q is equal to 1 coulomb, then W is equal to ZQ is there, W is equal to ZQ. And if Q is equal to 1 coulomb, then W and Z both are equal. W is equal to Z, W is equal to ZQ, and Q is equal to 1 coulomb. Then W is equal to Z. Then what is the W? That is the Z. Correct? Hence Z you can define. Hence electrochemical equivalent. Hence electrochemical equivalent of a substance is equal to the weight of the substance deposited by 1 coulomb of electricity. Means if you pass 1 coulomb of electricity, then how much metal deposited? That is actually Z. Means electrochemical equivalent. Hence electrochemical equivalent of a substance is equal to the weight of the substance deposited by 1 coulomb of electricity. Now second law of Faraday's. Faraday's second law of electrolysis. What it tells? Then it states that when the same quantity of electricity is passed through the solutions of different electrolytes, the weight of the ions deposited are directly proportional to their chemical equivalent. Chemical equivalent. Okay. Chemical equivalent is different and electrochemical equivalent is different. You remember, don't confuse. Electrochemical equivalent is different and only chemical equivalent. Electro you have not added, only chemical equivalent. That is different. That is actually equivalent mass or gram equivalent. That is the equivalent. That is the called chemical equivalent, means gram equivalent or simply equivalent. And but here electrochemical equivalent is different. I told you that Z value, that is the amount deposited by 1 coulomb. Now Faraday's second law, I was telling you that what is actually second law of electrolysis. Then it states that when the same quantity of electricity is passed through the solutions of different electrolytes, the weight of the ions deposited are directly proportional to their chemical equivalents. Means suppose same current you are passing through three types of electrolyte, means 3 cells are there, you are passing same current, and all 3 cells have different type of electrolytes. Correct? Different solutions are there. Then what will happen? Now here only two, suppose you are passing through two different solutions. Then here suppose one was the copper sulfate solution, other was silver nitrate solution. Suppose it was there. and you have passed the same quantity of electricity you have passed. Then weight of copper deposited divided by weight of silver deposited, that is equal to equivalent weight of copper divided by equivalent weight of silver. Means you can tell copper is directly proportional. Weight of copper is directly proportional to the equivalent weight of copper, and weight of silver deposited is directly proportional to the equivalent weight of silver. Correct? That's why you can write comparatively weight of copper deposited divided by weight of silver deposited, that is equal to equivalent weight of copper divided by equivalent weight of silver. Because weight of copper you have written upside, then this side also equivalent weight side also it will be upside. Okay, then weight of copper deposited divided by weight of silver deposited, that is equal to equivalent weight of copper divided by equivalent weight of silver. Now what is the 1 Faraday, 1 F? Always you will use this term. What is 1 Faraday? Then 1 Faraday is the quantity of charge. Actually it is the charge. 1 Faraday is the quantity of charge carried by 1 mole of electron. Mole means Avogadro number, you remember. Then 1 mole of electron, 1 mole of electrons means charge carried by 1 electron carry the charge, you know. Each electron carry the charge. Then Avogadro number of electrons, how much charge it will carry, that is the 1 Faraday. Then 1 Faraday is the quantity of charge carried by 1 mole of electrons. Hence you can tell 1 F is equal to 1.6023 into 10 to the power 19 coulomb. Actually one electron carry how many coulomb charge? How many charge? Then 1.6023 into 10 to the power minus 19. You remember this value also. This is useful, very useful. Then 1 electron carry how much charge? Then 1.6023. 1.6023 into 10 to the power minus 19 coulomb. Then Avogadro number. If electrons are in Avogadro number, then just multiply by Avogadro number. Means 6.022 into 10 to the power 23. Then what you will get? You will get 96,490. After multiplying both, you will get 96,490. Roughly means roughly you can tell 96,500 coulomb. Means 1 F is equal to 96,500 coulomb. And exact way 96,490 coulomb. Then here you have understood the meaning of 1 coulomb and its value also you understood, and how 96,500 comes, that also you have understood. Means charge into Avogadro number you multiplied. Correct? You got the 96,500 coulomb. Now I am telling you reaction. Actually I told you that reduction is considered as a standard, not the oxidation. According to IUPAC, reaction is considered as a standard. Then reduction you can write in a general way. M, capital M, N plus. N means a small n. N plus. Then M may be 1 plus, M may be 2 plus, 3 plus, etc. You don't know. That is why in general you can write N plus. N may be 1, N may be 2, N may be 3, etc. Then metal M power N plus. Then same number of electron will come Ne. then it will convert to M. Correct? N positive, that will be neutralized by N negative. N suppose it is a 2. The 2 positive will be neutralized by 2 negative. That's why Mn plus Ne. In reduction, what happens? Gain of electron, then metal ion positive means cation will take the electron. Then it will convert to metal. Means Mn plus Ne. Ne has negative charge. Remember, then it will give M. Then here N means Faraday. Here you remember, N means number of Faraday. And 1 Faraday means how many coulombs? 96,500 coulomb. Then here Mn plus Ne, it will give M, capital M, means it will convert to metal. Correct? Mn plus Ne, reduction, it is giving M. Here N Faradays of electricity will be, you can say, deposit 1 mole of M. Here 1 Faraday, N Faraday, Ne means N Faraday of electricity will deposit 1 mole of M, capital M, metal. Okay, now further you understand, but 1 Faraday of electricity always deposit, 1 Faraday of electricity always deposits 1 gram equivalent weight of the substance. You remember this point, important point. 1 mole, wherever 1 mole will come, 1 mole means gram equivalent weight. Then here 1 Faraday of electricity always deposit 1 gram equivalent weight of the substance. Hence, 1 Faraday means 96,500 coulomb. It means 96,500 coulomb will deposit 1 gram equivalent weight. Then 1 coulomb, how much it will deposit? Then divide it, equivalent weight divided by 96,500. That is the, you can say, amount deposited by 1 coulomb. 96,500 coulomb deposit 1 gram equivalent means 1 mole. Then for 1 how much? Equivalent weight divided by 96,500. Correct? 1 mole, that is also you can tell here gram, that is equal to gram equivalent. Both are equal. 1 mole means 1 gram equivalent weight. Correct? Then 96,500 coulomb deposit 1 gram equivalent weight. Then for 1 coulomb how much? Just to divide by equivalent weight divided by 96,500. And this amount actually whatever will come, that is equal to Z. Z means electrochemical equivalent of the substance. Equivalent weight means amount deposited by 1 coulomb. 1 coulomb, that is called electrochemical equivalent. Electrochemical equivalent Z, electrochemical equivalent of substance, means electrochemical equivalent of substance is equal to equivalent weight of the substance divided by 96,500. Okay, what are the difference between electronic conductor and electrolytic conductor? Today's last point I want to discuss. Difference between electronic or metallic conductor, electronic / metallic conductors, and electrolytic conductor. What are the difference between these two? Electronic conductor and electrolytic conductor. Electronic conductor is also called metallic conductors. Then what are the difference in electronic conductors and electrolytic conductors? Now I am telling you. First point, electronic conductors. Flow of electricity is due to the flow of electron. Here remember, now through the copper wire current flows, that is due to the flow of electron. In wire, copper wire, aluminum wire, in house wiring is there, there current flows, their electrons flow, actually flow of electron is called current. This is the one definition. But in water or in a solution, flow of charge is called current. You remember. Then here in metallic electronic conductor means flow of electricity due to flow of electrons. Flow of electricity is due to flow of electrons, okay, under electronic conductors. And here in electrolytic conductors, flow of electricity is due to flow of ions. Ions may be cations or anions. Then in electrolytic conductor, flow of electricity is due to flow of ions. Electricity is due to the flow of electron also and due to the flow of ions. Now second difference, flow in electronic conductors, flow takes place without decomposition of the substance. Now you have seen in copper wire current will flow, then there will be no loss, no decomposition of the wire. Hence in electronic conductor means metallic conductor, flow takes place without decomposition of the substance. But here in electrolytic conductor means a solution like NaCl solution, KCl solution, copper sulfate solution. It will produce cation and anion, Na plus Cl minus. If KCl is there, then K plus Cl minus. If copper sulfate is there, then Cu2 plus SO4 2 minus. Correct? Then in electrolytic conductor, flow takes place without decomposition of the substance. But here in electrolytic conductor, flow is accompanied by decomposition of the substance. And the third difference I want to tell you, for electronic conductor, conduction decreases with temperature. Conduction decreases with temperature. Why? Because kernels start vibrating, which interfere in the flow of electrons. Here kernel, you know, that is like orbit. In atomic structure you have seen different electron flow in different orbits. Okay, it is related to that only. Then conduction decreases with temperature in electronic conductor because kernels start vibrating, which interfere in the flow of electrons. And here in electrolytic conductor, conduction increases with temperature. Just reverse way here. There it was decreasing, but here it will increase. Conduction increases with temperature because dissociation increases. In electrolytic conductor, conduction increases with temperature because dissociation increases. Okay. Then today I am stopping only here. Next class again I will continue. Thank you.